This lesson is on writing equations using point-slope form. So thinking about the title, point-slope form, you can tell from an equation what the slope is and a listed point that is also on that line. So point-slope form is the form of an equation of a line that passes through a specific point and has a slope of m. And so we note the slope m. This is the same as slope-intercept form where m represented slope. And the x1, y1 of our point-slope form equation, those just refer to the coordinate of a point on that line. So here are some examples of equations that are in point-slope form. This first one here, I can see that here is the slope of our line and the point, our x-coordinate and our y-coordinate. And this equation here, we can see our slope of 1/2, our x and y coordinates, and this last one, the slope of a -3/4, and our x and our y coordinate. So writing an equation in point-slope form is the easier step of this lesson because you're given the point that you need to write the equation using and you're given the slope. So it's as easy as just replacing the values, where y1 is your y coordinate, m is your slope, and x1 is your x coordinate. So if we were to write this in point-slope form, we would have y minus our y coordinate, so 5, equal to m. M is our slope, so a -1/2, times x minus our x coordinate, and our x coordinate is 3. So here this equation is written in point-slope form. We can see the point 3, 5, and the slope of a -1/2. The other x and y just represent another point, any other point that might be on that line. But in terms of writing the equation, you're going to leave that x and that y as is, as those variables. Another example, plugging it in, this time we have the point -1, -4. So when you're writing these ones in, this is a little bit different because these are both negative coordinates. So when we replace them in for x1 and y1, make sure that you identify that the y coordinate is a -4, so y minus a -4 equals our slope of 3 times x minus a -1. Don't get confused thinking that this subtraction takes the place of this negative. You have to make sure you show that you're subtracting a negative number. So then simplifying, we want to make sure we add the opposite. So this is actually the same as y plus a +4 equal to 3 times x plus a +1. So what's important to note is our original coordinate had negative numbers. Notice how the equation looks. The equation has addition for both of them. Make sure you are mindful of that because when you have negative coordinates here, when you translate it into a point-slope form equation, it ends up switching to addition because you're subtracting a negative. Whereas in this previous example, both of our coordinates were positive. So when you fill it in as y minus that coordinate, it's still showing subtraction for each of these. This is probably the most common mistake that students will make is when they're trying to write the equation from the graph and they're using the coordinates, or they're trying to pull the coordinates from the equation. They get confused on what the values actually are. So just kind of think of it as it's the opposite of what is shown. So an example, with this one specifically, I need to graph this line. So I can see that the slope is 3/4. So I know for sure that that is the slope. However, I can see coordinates on this line. I know I need the coordinate x1 and y1. So if I look where x is, where my x1 would be, this ends up being a +3. But if you remember, if we had written this in like this equation, it would have been x minus a -3. So the x coordinate is actually a -3, not a +3. So just think about what the original equation looked like before you plugged those numbers in. Both of them were subtraction. So if you see in your point slope form equation that it's addition, just know that you were subtracting a negative. That's why it switches to addition. So our coordinate is actually -3 for x. And our y coordinate, if you think of this as y minus y1, then our y coordinate is just 1. So once we have our ordered pair, we can graph that, -3, 1. Here's that point on our graph. And then since we know our slope is 3/4, we can count on our graph a rise of 3. So 1, 2, 3. And a run of 4. 1, 2, 3, 4. Getting our second point here. And then you can connect those two. There is the line that goes through those 2 points. So this is the tricky part, is students forget that the original equation is actually subtracting the y coordinate. So if it's showing addition, it's actually a negative coordinate. Make sure you remember that. Make note of that. Circle or star this for your notes so that you can see that when it's addition, it's actually a negative coordinate. Okay, let's take a look at this graph, and we need to write the equation in point slope form. You can choose either point. So when you're setting up and you're choosing x1 and y1, you can choose either point. It doesn't matter which, just know how to write it with either point. What you have to calculate out, though, is the slope. So we need to find m, which is the rise over the run. So between these 2 points, if I start at this point and I count up until I'm in line with this point, that's 1, 2, 3, 4, 5, 6. So we had a rise of 6. And then a run starting here, 1, 2, 3, 4, 5, 6, 7, 8. So we had a run of a positive 8. And that always make sure that you simplify your fraction. You reduce that fraction. So in both the 6 and the 8, there's a 2. If you divide out that 2, 6 divided by 2 is 3. 8 divided by 2 is 4. So this one has a slope of 3/4. So I know that m is equal to 3/4. So the next step is just writing the rest of your equation. You can choose either point. If you choose this point, here is your x1 and here is your y1. So y minus 4 equals 3/4 times x minus 2. So there's one possibility for your point slope form equation. The other one is using this point. So y minus a -2 equaling our slope of 3/4 times x minus a -6. So since we're subtracting negatives, make sure you rewrite it to an add the opposite problem. So y plus 2 is equal to 3/4 times x plus 6.